Hello, this video is about dividing variable terms with exponents. What's important about this rule is you must have the same base and then you subtract the exponent. You have to say numerator minus the denominator. And then you divide or simplify the coefficients. Okay? Remember, when it's written like a fraction, it means division. All fractions are division problems. So I'm going to look at this one. Let's try 4m cubed divided by 2m, okay? So I look at my rule and it says simplify or divide the coefficient. So 4 divided by 2 can be simplified to just a 2 in the numerator. The rule says as long as I have the same base and I have m's, I take the m and I say m 3 minus 1. Remember, there's an understood 1 here. So it's actually 3 minus 1 like that. And that can be written as 2 to the m to the second power. 2 times m to the second power, or m squared. Let's look at this one. So negative 2 is my coefficient, and there's an understood 1 coefficient here. So the negative 2 stays there. I look at my x's, and it's x to the 4 minus 5. That's my rule, is I have to subtract the numerator minus the denominator. I have to do my math for that, and remember my integer rules, and it becomes negative 2 times x to the negative 1. That can be written as negative 2 on the top and the x on the bottom. Only the x goes on the bottom because that's the only one that's raised to the negative 1. The negative 2 has an understood 1 as your exponent, so it stays there. Okay, so let's look at the next example. 3 divided by 18 can be reduced. Just think of a fraction that's 3/8. So 3 can go into both of them and it becomes 1/6 like that. I'm going to look at each of my variable terms. I have x's and y's. I'm going to do one at a time. My x to the third minus the 5, that's these two, okay? And then I'm going to say y 5 minus 1. Remember, it's an understood 1 here if you don't have one, so 5 minus 1. That can be written as, it's still a 1/6 is here, 1/6, and I have x to the negative 2, y to the 4th, okay? So if I wanted to rewrite that having only positive exponents, then I would just have the y to the 4th on top and then the 6x squared on the bottom. And that's how I would write that with positive exponents. If you have a quotient, remember quotient is an answer to a division problem and it's raised to the second power. The whole thing, everything inside must be raised to the second power. So it needs to be written as 2 squared, x squared over y squared. The 2 squared is a nice enough number that you can actually multiply that out to 4x squared over y squared. Let's look at this next example. Everything inside must be raised to the third power. Don't forget to raise the 4 and the 2. So it's 4 cubed x. Remember, our rules for this are you have to multiply. That's from another video. And then y to the third over 2 to the third, x to the third, y to the 9th right here. Okay, now once I do this, now I have to do my division rules. So I'm also going to multiply 4/3 and 2/3 out. So 4 to the third and 2 to the third. So that's 64. And then I'm going to look at x to the 6 minus 3, which is 3. And then y to the 3 minus 9, which is negative 6, and that's over 8. I'm going to simplify the 64 over 8, and that's going to be an 8. I'm going to keep the x cubed on top, but I'm going to bring the y to the 6th on the bottom. Remember, when I bring a negative exponent, it does not make a negative number. It just brings it to the bottom if it's on the top, or brings it to the top if it's on the bottom. Okay? All right.